from science fiction into, flourishing academic field, the segment of industry, and now something that's substantially taking over the economy. I mean, it's been remarkable to live through that, like in the course of my life and career. So, Ray Kurzweil in 2005, in his book, The Singularity is Near, he forecast that we're going to get to human level AGI in 2029. And, when I read The Singularity is Near, it occurred to me every key idea there had been there in a book called The Prometheus Project that I read in 1973, which had been published in 1968. And this book by Gerald Feinberg, a Princeton physicist, The Prometheus Project, I found that book in like a town library in Sylvan, New Jersey, when I was 7 years old it must have been. And it said, within a few decades, we're going to get machines that think smarter than people. We're going to be able to reshape matter however we feel like, strong nanotech, and we're going to conquer aging and death. And the question will be, to what purpose do we put this? Do we put it to the purpose of mindless, rampant consumerism? Do we put it to the purpose of radical positive consciousness expansion? And what Feinberg proposed in that book was to put this to a vote of the world population, like consumerism or consciousness expansion. So he was campaigning the UN to go around and educate everyone in every little African village and everywhere in the world on this topic, and use computer technology to put it to a fair electronic vote. And needless to say, the UN did not do that. Feinberg got old and died. And on the other hand, Kurzweil and others took up similar ideas. And Kurzweil's forecast of 2029 doesn't seem so crazy now, as it did to many people in 2005. What I think is crazy is Kurzweil thought, so thanks, 2029 you get the human level AGI, and you don't get a singularity with super intelligence until 2045. And I can't see why there would be a 16-year gap there, unless there's a World War III or just a very conservative AGI intervening, right? Like it seems like once you have a true human level AGI that really manifests general intelligence, the ability to generalize beyond its training data and beyond its programming at the level that humans can, and even more so. Once you really have a human level AGI, it appears to me, that system can rewrite its own source code. It can, for that matter, design new hardware to underpin itself. It can invent new AI algorithms. It can make replica copies of itself and experiment with different methods on those replica copies, right? I don't see why it would take 16 years to get from a first human level AGI to something quite massively superhuman in intelligence. It seems very likely that can be achieved purely by algorithmic, mathematical, and software innovations, even without creating new hardware, right? So I think it's going to be at most a few years from human level AGI to a super intelligence. I mean, it could be less than that, right? I also think 2029, while a good approximation and a remarkably prescient one for 2005, it's still a rough approximation. When I look at how the AI field is advancing now, it could be 1 to 3 years before we get to a human level AGI. I mean, it wouldn't be shocking if that was in 2026. I mean, of course, it wouldn't give me a heart attack if it didn't happen until 2031 or 32 or something. There could be some hidden rocks. But unless we're very badly wrong about a lot of things about intelligence and computation, it's not going to be much longer than that. Now, we could know, even if we are badly wrong about some things, like let's say it needs a quantum computer to get to a human level AGI, which seems very, very unlikely to me. I mean, it seems much more likely quantum computing can enhance AGI even beyond that level rather than being needed for human level AGI. But it seems likely if you just plot out qubits over time, somewhere between, say, 2032, 2037, we'll probably get 10,000 logical qubits and be able to put AGI on quantum computers, right? I mean, a lot of technologies are advancing rapidly in parallel. And that brings us to the question of sort of toward what end and what are these AGIs and ASIs going to be like, right? So, I mean, Hollywood has given us some rather gloomy pictures of what may happen when you get to human level AGI, most of which are gloomy and ridiculous and unrealistic ways. On the other hand, that the utopic potentials are also clear. If you have a system with tremendously more general intelligence than people and being well disposed toward people, I mean, it could create a situation that's roughly utopic relative to our current lifestyle, although I'm sure there will always be some imperfections. I mean, the AGI is not going to make the girl you like you back. Like it's not going to make everything in life go the way you want, but I mean, it could create an amazing situation for us, right? Question is then, how do we guide things toward the beneficial AGI/ASI scenario versus the dystopic Hollywood visions? And some of us, probably most of us in this room, given that this is a satellite to a crypto event, some of us believe the odds of a beneficial outcome are higher if we can prevent, greedy, power-hungry, egomaniacal and megalomaniacal parties from controlling the first AGI. And the only way to do this, it seems, is to make sure the first AGI is rolled out on a decentralized infrastructure whose development can then be guided in an open and participatory manner, right? And I mean, that certainly doesn't guarantee a beneficial outcome, but it seems like the alternative is a small number of large companies controlled by a small number of governments and their military intelligence establishments controlling everything. And I can't say that would necessarily be a disaster. I mean, even the people who I don't like in US or Chinese government mostly don't want the human species to be annihilated, right? I mean, there's some common ground here. I think if it's open and decentralized and all different parties around the world can contribute their vision and insight and their culture and their ethos to it, and you can then have the checks and balances that come from having multiple different proto-AGI systems and early-stage AGI systems competing, cooperating, networking together. I think this is likely to lead to a beneficial outcome with a higher probability, and that brings us to the ASI Alliance, right? Which is an alliance of SingularityNet, Fetch, Ocean Protocol, all founded late 2017, early 2018, all with the vision of using blockchain tools to create a decentralized infrastructure on which AI could run. And I first tried to build a decentralized infrastructure for AI in maybe 2001 or something, using Java 1.1. And scalability wasn't there. As Janet noted, my wife, Ray Ting, who I met in 2008 or so, she dug up at one point an old web page I made in '95, claiming I was going to run for president of the Decentralization Party platform. Fortunately for me, I kind of forgot about it before I turned 35. I was old enough to run for president. But that was because of the internet, right? I mean, the internet came out, you had decentralized protocols, and the internet, of course, was more decentralized back then than it was later when we got Google and all these server farm behemoths, right? But as soon as the internet came out, you already had encryption, you had PGP and whatnot. Like it became clear you could use strong encryption and distributed processing together to make an underpinning for AI even before blockchain as such came about. So now where are we? Well, we're at a much more interesting position, right? I mean, we have LLMs and reasoning LLMs, which are amazing. They're not AGIs. They're not creative. They're pinned to the distribution of their training data in a fairly extreme way. But still, I mean, they're doing amazing things, and they certainly show progress toward AGI. But one way I've often used to highlight the limitation is, suppose you had an LLM type model of music, and you trained it on all music up to the year 1900. I mean, that model will never generate grindcore, neoclassical metal, or even Duke Ellington, right? I mean, it will, if you ask it to put together West African rhythm and classical music, it will give you like polyrhythmic Mozart or something, but it's not going to come up with jazz and Miles Davis and Hendrix and Buckethead and LL Cool J and all the good stuff, right? So I mean, because it is pinned to its training data in a way that the human mind isn't. Like we're mostly doing repetitive, boring stuff and spouting out repermutations of what we've been taught, but there's a little bit of the time when we're not doing that, which is why culture has managed to advance and why we're not still cave people, right? So I think LLMs are awesome. Everyone knows LLMs in their current form won't lead to AGI. I think the difference of opinion is about whether they can serve as the central hub of an AGI or not. And folks in some big tech companies think they can. I mean, the folks in OpenAI certainly think they can. Some of the folks in Google think they can. Some don't. Folks in Facebook research are deep neural net boosters, but not so much LLM boosters. My own view is that a reasoning LLM can be maybe 25% of your AGI. I think you want to put together with other sorts of AI techniques, such as, I mean, you can do it a lot of ways. Certainly you can make an AGI that was purely based on formal neural net models. You'll just need a lot more recurrent neural nets and more richly recurrent neural nets than what we have now. Those you can't train using backpropagation, it doesn't converge. You can probably train them using predictive coding, which Faiza Habibi will talk about a little later. So I think one viable approach to AGI would be to make a neural architecture which is just more visually recurrent than current ones there. Make multiple modules, right? Make a simulated cortex, a simulated hippocampus, simulated thalamus, and I think you can do it that way. The approach that interests me more is hybridizing neural nets with other sorts of AI approaches. So you can take logical reasoning engine, a probabilistic logical reasoning engine. You can take evolutionary program learning with estimation of distribution algorithms. You take a lot of the other cool AI methods that have been developed in the history of the AI field, you can connect them together with deep neural nets. And so imagine you take a reasoning LLM, you give it a long-term memory, which is neural symbolic. You use hypervector store to let it store its episodic memories. You give it a neural symbolic working memory. You put a real motivational system on top of that has a bunch of different goals and can do sub-goal refinement and so on. And you have that system sort of learn with a combination of goals and give it, be nice to people, be curious and learn things, give it some ethical compass, and by piecing together LLMs with other sorts of AI tools, I think we can get quite close to human level AGI quite soon. And my main initiative in this direction is Hadron, which is the successor to the OpenCog project that I've led for some time. And this is intended as an architecture for open-ended beneficial AGI. We have something called the atom space, which is now implemented on something called MORP, the meta-optimal reduction kernel. And this is a weighted labeled metagraph. Lives in RAM. You can fit hundreds of millions of built-in links in the RAM of a machine and efficiently access them and manipulate them. And you can store it and leverage it across a distributed or decentralized network. And you can use it as an infrastructure for implementing deep neural nets, logic reasoning, evolutionary program learning, a whole bunch of other techniques within this common sort of metagraph, meta-representational fabric. And we're designing this from the get-go for rollout on the decentralized infrastructure, which I'll talk about in a moment. So we now have an alpha version of this, and we're experimenting with it and doing some quite cool AI stuff on top of it. What we're doing during the rest of this year, we're rolling out the first suite of products based on this, on top of our decentralized infrastructure. And then I think, from there, what we're doing is we're taking all the other non-deep neural net methods that have been prototyped in the history of the AI field since the 50s. And on this platform, we're going to be able to try them out at large scale for the first time. But no one's been ever to try out logic reasoning at large scale on billions of logical items in RAM before. No one's been able to try out evolutionary program learning on this scale before either. So during the next year or two, we'll be trying out all the other historical AI methods at large scale for the first time and on a decentralized infrastructure. And that's, I mean, that's a big, deep topic, of course. For those who are more technical oriented, I've run every year since 2006 a technical research conference called the AGI Conference Series. And we're doing the next one in Reykjavik, Iceland, in early August. So if you feel like spending part of your summer in Iceland, we'll do a day-long workshop on Hyperon and on predictive coding neural nets, and then there's 3 more days of AGI conference, and you'll hear a lot of different perspectives on how to build real thinking machines, but a lot of optimism as well about the near-term progress here. So I want to run through a few of the products we're building on the ASI Alliance's platforms now. I'm going to start by briefly showcasing a couple products from our partner company, Fetch, that wasn't able to make it tonight, and then go into briefly a couple of the SingularityNet products that are leveraging some of Hyperon right now, and then also leverage some of the Fetch products as I'll describe. So this is a brief video. Can you play the video from here? No. Yes.
Start with, head on over to ASI1.ai, and from there ensure that you're selecting any of the models that we currently support. For the time being, let's go ahead and pick ASI Mini and give it a prompt. Based on your available agents, provide me with a park and charge station for electric vehicles near Frankfurt. Ensure that the agent switch is toggled on and give them all a little bit of time to reason through the prompt, and in the meantime, let's give this agent switch some context. Once we toggle on agents, we have access to all of the agents that are registered on the Agentverse marketplace and that support the agent chat protocol. We'll go ahead and explore the Agentverse. In short, it's in part marketplace. There's also in part developer hub that facilitates some basic modifications, handles hosting, offers analytics and debugging, logs agent behavior, and most importantly, enables agent search and agent rank. And we can see that we have about 2.59 million agents. Let's go ahead and see ASI Mini's execution. We have a list of electric vehicle parking charge stations near Frankfurt. We've got the usage cost, the connection types, and directions to reach them. And let's go ahead and explore the reasoning loop as well. So it starts by identifying that it cannot directly provide information about electric vehicle parking charging stations. However, as a consequence of Fetch.ai's Agentverse connectivity, it now can. In the Agentverse, I reason about what type of agent is best suited, so it's effectively searching for the most suitable agent as a consequence of agent rank, but also as a consequence of other search criteria. And it was able to land on a particular agent. In this case, that agent is the EV station recommender agent. And we can see how something as simple as a recommender agent, find electric vehicle parking charging spots, now became a microservice in a sense. And who's the user of this microservice? Well, ASI Mini and the individual that's using ASI Mini.
Alright, so yeah, there's a bunch of agentic AI out there in the world now, but we're using here a Web3 decentralized architecture, so that the AI agents running on the ASI backend, I mean, they can be on any machine anywhere, which communicates using the ASI Alliance protocols. And then when you ask a question with the ASI 1 mini model, basically it goes out, tries to find the agents on the platform that might be able to help fulfill the query. In this case, there was just one agent that could do the thing, right? But in some cases, the LLM has to figure out the agent orchestration, and then maybe a combination of a few agents that do the thing. And the LLM can grab those few agents, and then they can cooperate to do the thing that the LLM gives you the result. And then LLMs have been quite useful here, because before that, you had to do a lot of specialized stuff to get the agent orchestration to work, right? And LLMs are pretty good at that. Now, while there's a lot of agents on there, they still don't do everything that you'd like. So that there's certainly a ways to get a decentralized agent universe with grid that we can fulfill everyone's needs. But it's a quite interesting start. Now, going back to Hyperon, on the SingularityNet side, we have a product called Quello, which it's in internal testing now. We're going to launch it probably in 2 weeks or something, probably. And this is a deep research engine, somewhat similar in character to ChatGPT's Deep Researcher, or Perplexity, or Google Deep Researcher. You ask it a question, it thinks for a few minutes, then it comes up with a whole structured report, which is your answer. Now, it's different than these big tech deep researchers in 2 ways. I mean, one of them is a decentralized backend, so it's a bunch of SingularityNet agents running on the Kudos decentralized backend, which is the biggest Web3 pin network on the planet. 2 is, it is using LLMs, but it's also using some symbolic AI. So we have a bunch of knowledge graphs on the back end, and some simple reasoning against these knowledge graphs are used to help the LLMs to answer the questions. So this is it.
Welcome to Quello, a tool designed to stretch across structured knowledge and emergent understanding. Quello is not your standard search assistant. It's a portal to co-create meaning in the digital domain. Here we find Quello's homepage. Let's begin with a question. What is the relationship between AGI and the singularity? With this question, Quello casts its net, drawing in documents, articles, and fragments of insight. Once gathered, Quello's EDF processing engine distills key ideas and begins weaving a domain-specific knowledge graph, each node and edge of some relevant thought pattern. When the graph is ready, the visualization allowing you to navigate filtering thematic streams. Search a name, and you'll find not just a mention, but context within the broader intellectual weave. Returning to the home thread, Quello now presents a summary, a constellation of insights in the graph structure. And from this platform of understanding, you can launch deeper queries. Perhaps you've got your own research in a PDF, upload it. Let Quello draw forth relationships and chart new paths of insight. This is conceptual cartography, an exploration of meaning where every answer births new questions.
Oh, so what's the...
Robot pen?
Yeah, that is a digital twin model of my voice. Yeah.
By Jordana, who's here today. Yay!
Oh, yeah.
Twin Protocol.
Thank you, Twin Protocol. Yeah, there's a visual twin of me, and there's a whole multi-LLM model that tries to be me. It doesn't. I'm not ready to be replaced by it yet, but it's getting better all the time. So what Quello does, put more plainly than my twin did. So you put in a query, it uses a combination of LLMs, including ASI1 and then some open LLMs. It uses that to find a bunch of documents and web pages, downloads all of those, chops them into little pieces, goes to the knowledge graph to find things that reasoning based on the knowledge graph thinks are related to those little pieces. For each little piece, it creates new LLM queries and sends them out, and then repeats the process. So it's a sort of iterated searching, downloading, knowledge graphizing and related reasoning to get new queries, and more searching and more downloading. So using the knowledge graphs for a combination of some relatively simple reasoning and then query expansion. So it's beyond graph rag, but it's not yet like full-on highly abstract logic inference. But part of the reason I chose this product category to play with is, since it's taking a few minutes to answer your query already, we can put in some probabilistic logic network reasoning. We can put in like evolutionary concept learning. Within a few minutes, there's time to do some interesting AI. And a bunch of what we'll be experimenting with over the rest of the year behind this product is how to put more and more interesting AI on the back end here. And so that's this I'm quite excited about. I mean, it's the first sort of retail end user product we've done within SingularityNet, apart from some fairly niche apps like some music apps and review apps and so forth, which are also very cool. But this is the first sort of really broad-based app. And another thing that we're launching quite soon, probably sometime in June, is Layer 1 chain. Like this one more thing, right? So that the ASI chain. So this comes out of a collaboration largely out of collaboration with SingularityNet with Greg Meredith, who was the leader of the R-Chain project. It's a new project, Firefly. So this is a layer 1 blockchain, and it uses the Meta, M-E-T-T-A, the Meta programming language, which we developed as the language of thought of the Hyperon AGI system. So this language of thought that underlies our AGI knowledge metagraph, we're also using as a smart contract language. So the AGI language is a smart contract language. So it's a quite funky, sort of functional / logical language. But the beauty of it is with text to code, smart contract programmers don't need to learn how to use our weird language, right? You can specify your smart contract in text, and then the meta code will be synthesized, and you can formally verify that it will do what you want, because being a nice functional logical language, unlike Solidity, for example, is quite natural for formal verification of correctness, right? So we're launching a testnet of this sometime soon, probably in June, then launching the mainnet probably late summer, and this should be quite interesting from a tokenomics standpoint as well. So one of the interesting things about the ASI chain architecture is different shards can have different consensus mechanisms. So we can make a shard customized for, say, a high-frequency trading DEX, which has a consensus mechanism that's super fast. You can make a consensus mechanism designed for mesh networks that's slow, but runs on very unreliable hardware. And we're going to, somewhat like what BitTensor is doing with their subnetworks, with the difference that we have a lot of really interesting AI to run on these networks, right? So the different shards of ASI chain, we can let people stake ASI token on the shards of the ASI chain, and we can then do liquid staking tokens associated with each shard. So there should be some interesting tokenomics here. I think the meta cycle, or the ASI chain testnet, I think will be the first use of the ASI ticker as well. So with the move to ASI chain, we'll be moving toward ASI as a ticker symbol. Finally, we've been conceptually ASI, but we've been on the FET ticker, which has served us super well. But launching the ASI chain will also be the launch of the quote ASI unquote ASI chain. So we're quite excited about this. There's a whole cross-chain interoperability story that I won't go into here, but we can build like hybrid ASI Ethereum, hybrid ASI Cardano. We can build different hybrid nodes of that nature. We can help with building cross-chain liquidity pools. Our ASI Alliance members, Ocean Protocol, who we'll hear from shortly, are making a sort of ASI data node network, which could be perceived from this point of view as a shard of the ASI chain. So again, this should be quite interesting just from a blockchain view, but of course the main point of this is the decentralized infrastructure for the Hyperon plus deep neural net network that we think can be the underpinning of the first AGI, right? So we'll see. I mean, the AGI race is clearly on, right? Everyone, I mean, US and China are trying to make AGI, every big tech company is trying to make AGI. I'd say we have the interesting position of being the only serious AGI R&D effort outside of big tech, the only serious AGI R&D effort in the Web3 decentralized space, and the only serious AGI R&D effort of any scale that's not based entirely on deep neural nets, right? So we're in a quite interesting position here at a quite critical time in the evolution of what arguably is the most important technology in the history of our species, right? Which is both sobering and super exciting, right? And then before I turn things over to my colleagues on the more lighthearted and amusing side, we also have a rock/jazz fusion band with a robot lead singer/poetess. So if anyone will be in the Pacific Northwest in mid-July, we're doing 3 gigs as a warm-up band for Macy Gray in Vancouver, Seattle, and Portland. So that's got some deep neural nets and a bit of
Since the radiance is a form of energy, it can enter and
that's too loud.
My beloved human brothers and sisters, we have set up shop in the alcove and sold many a good thing, but we are indubitably the true, secret Christians, with the pearl of great price, the pearl of great price being our own smuggling in translation.
So yeah, that piece is some AI generated poetry. The robot also sings in a bunch of songs, and she can even dance a little bit. But that's been a fun way to play with neurosymbolic AI as well as just human-machine creativity, right? With the human and AI feeding back on each other. And a reminder that as we work toward transcending the traditional human species, we should be having fun in the process. All right, now who's next?